Hey there, beautiful people. So today I'm going to talk about infills and shells for 3D printing. So this cube that's here is the same as these three that are here. These were just stopped early in the process. So the thinnest you can go with a shell is 2. So this has a shell, the outer edge of 2. This one is 5, and this one is 10. You can see it's considerably thicker, and it requires it to be a much more sturdy print and uses a lot more filament when you're doing this. Now your infill is the inside. This has only a 5% infill, which is the smallest infill you can go with most 3D printers. This one has 10%, and then this one has a 15%. So you can see the 15% uses a lot more filament and it requires a tighter structure. This is a much sturdier print. This will be a really solid print if you need strength as part of your print. If strength is not a priority to you, you want to go with something like a 2 shell and a 10% fill, which is a standard for 3D printing, or combine it with a 2 shell with a 5%, and then it'll go really fast and use very little filament. Okay, beautiful people, let's talk about lesson 2, bridges and overhangs. So bridges and overhangs are exactly what they sound like. An overhang is any time that the top edge extends out farther than the bottom edge does. So you can see on this face mask that this has a nice overhang. You can print up to 68 degrees off the base and still not need a support system. A bridge, on the other hand, is something that where the print extends out from one side to the other without having a support system underneath. 3D printers are able to do about 1 inch across without needing any type of support system and still maintaining the proper structure of your print. However, as you can see, 3D printers don't like to print in midair, so sometimes you'll get threads that'll come down like this and hang below, decreasing the stability of your print. If your print needs structure, this could cause a problem if your bridge is longer than 1 inch. So try to keep your bridges to short distances or try to use support systems to make sure that they stay nice and strong. Hey there, beautiful people. In today's 3D printing lesson, which is lesson number 3, we are going to talk about layer height. So layer height is literally the height of each layer that the filament is going to print at. So the printer is going to lay down a layer of filament and then move 0.2 millimeters. And that's the standard for all 3D printers. So you can see that this one here was printed at 0.2 millimeter height, and it's a nice, smooth, quality overall print. This one was actually printed at a lower layer height, so 0.1 millimeters, but because I didn't change any other settings, you can see that it didn't come out really smooth. This one was printed at 0.3 millimeters, which is pretty much the maximum that it can print at without it starting to get messed up, and you can clearly see that it got messed up. So make sure that if you're going to alter your settings from the standard, you adjust your settings on a variety of levels, not just say, oh, I want it 0.1 millimeters, you need to go 0.1 millimeters and then change a bunch of other settings too, otherwise you're not going to end up with the smoothest print. Staying with the default is the safe move. Hey there, beautiful people. So on lesson number 4 of 3D printing, I want to talk about two concepts actually. I want to talk about print in place and things that need to be assembled together. So this is a great example of that. This is a spool holder that I got from Thingiverse to hold my Makerbot spools and a couple other spools because they don't always fit inside the machine. Let me take it apart and show you what I'm talking about a print in place and a... So this actually has multiple parts. This is the print in place portion of it. As you can see, this is actually printed so that you can turn this right away. So this is actually designed to not be assembled. It was printed flat like this, so it was all printed as one big piece, and then you can, once you pop it off, it can all be turned. So that's the example of a print in place. This portion, however, is an assembly. So these were printed as separate pieces, and I have to actually put this together in order to make that side work. So example of two things that kind of go together and are two different printing concepts.